Alrighty, welcome back everybody to the 6th week of our algorithmic programming course in the language of Python. This is a Tech Bytes program and we have made it to the 1.5 month mark on this President's Day. Hopefully all you guys are doing well. Seems like you guys are doing well, and as for today, we have a sort of a different class planned with a more of a connection with our project development course. And if you're curious what that entails, you can find that on the Schaumburg Library's website as well. But that's a program which we do every single Wednesday where we actually make projects. We just recently made Mastermind, and you'll see how we're going to be doing some sort of types of things with Mastermind today as well. So thanks for coming in. Without any further ado.
So we're working on Mastermind in this class today?
So you'll see we're actually going to do sort of an exercise which involves critically thinking about how we can make our code better. But more about that in a little bit. You guys know who I am already, guys. My name is Rayan Sadikia, senior at Conan High School. The catchphrase, it's like Alexa. You know it. You should have memorized by heart. There it is. Learn, play, code, sleep, and repeat.
And my name is Labdi, also a senior at Conan.
Alrighty, so let's get down to today's agenda for February 15th. We're going to start off with any questions you guys might have, and then start getting on this idea about abstraction with our mastermind game. Now, abstraction is a word which we haven't really talked about that much, and it's going to be our main focus for today to make sure that once we leave, we all have a clear understanding what is abstraction and how are we going to use this idea and apply it to our project, which we just finished last Wednesday. And then we'll do, this is a webinar, so we'll just talk amongst ourselves and about some terms coming up as well.
Yep, and as Rayan said, today's idea of, like we have problems every Mondays on algorithmic programming sessions, today instead is an idea of abstracting our code from the mastermind project that we finished in project development class last week. And you guys might think, we finished that code, why are we going back to it? Well, that's the idea of abstraction, which we will learn today.
Exactly. So a bit of a untraditional, but it is definitely a good way to link our two classes. But now let's talk about what is this word which we've been using, abstraction. Well, the main idea is, have you guys heard of like art pieces? They say, oh, this piece is very abstract. Anybody ever heard of that? Maybe seen a movie, TV show. I'll take it probably not. So the idea is that something is pretty simple. It's nicely organized, not much to it going on. It's not some Picasso painting where you got 10 different things going on in one picture, right? It's more simplified down, and you can clearly tell what's going on in the image. Well, similarly, in code, the idea of abstraction is to take our code, which is super unorganized. We got functions doing multiple things, and the idea is to tone it down. Make sure that each function has one purpose. Make sure that each line of code has a true purpose. And the idea is to cut down on the amount of code we have to write. It's sort of like an English paper, right? An English language arts paper you might be writing for middle school, right? You have a paper you got to write, and there's probably a word limit. In your first draft, you're probably going to go a couple hundred words over. But then after you revise and go over that paper multiple times, you cut down immensely on the amount of words you've written. Well, similarly, in coding, this idea of abstraction is we make a project, nice, it works. Last Wednesday we played it, we had a bunch of fun. Our game was working perfectly. So what's the point of us having to go back and abstract? Well, let's talk about why it is actually important. And before we do.
And just before we do a quick discussion, think of abstraction as if I describe a fruit as red, crispy, sweet, and it grows on a tree, what would you say that is? An apple. So it's describing a fruit red, crispy, and juicy, or sweet, versus just describing it as an apple. Using that apple noun would be way more efficient, and that's the abstracted way of describing the same fruit using like 10 different adjectives. All right, so that was just an analogy just to explain what abstraction is a little bit more, but instead of breakout rooms today, we will just discuss within ourselves. We don't have too many people in this room, so I think that will be a great discussion. based on what Rayan said and what we have talked so far, what are your guys' thoughts on why we should use abstraction in our code? Anyone, you guys can unmute
It just
yourself.
makes it like cleaner and easier to like handle. And then you know like where everything is. Instead of just having like just a heap of code and you like if there's a bug you don't know how to solve anything.
You should bring in a Hack Central reference in here talking about heaps. Remember, Hack Central tomorrow. We got Krishna saying in the chat it can help make our code more precise. Absolutely.
Oh yeah, tomorrow's Hack Central.
Yep.
Yeah, definitely. So we got
and
two
Friday,
ideas.
we have game night again Friday.
Yeah, definitely. So regarding abstraction, why we use it, we got two ideas so far: to make it more precise and to avoid it's what we call spaghetti code in like the coding world. Spaghetti code is basically a bunch of codes, lines of code. Think about like a bunch of wires just intermingling into each other and getting knotted. Think about spaghetti code as a bunch of lines working, definitely working, but you don't understand what it's doing if you just like run through like with your eyes. Now, that's not what we want when we are collaborating with others, because that takes up time and it can cause many errors when we are coding. So abstraction takes that away and turns that spaghetti code, like a jumble of code, into structured code, which everyone or coders can easily read through and understand. That was one way. We had Krishna saying in the chat that it makes the code more precise. So definitely increase efficiency and decrease the complexity of our code. And now decrease the complexity of our code. Now, if you just think about it in regular terms, it makes our code more easier to read. But complexity in coding also means how long it takes your computer to run that code. Now, if you try to run through nested for loops, it's going to take longer for you to run through those loops than if you just have one for loop. That's just an example.
Exactly.
We have a question from Chase. So making an abstract code is like building a house. Rayan, were you answering that?
Yeah, so Chase, it's a good analogy. So sort of like say you're constructing a house, right? You wouldn't want to construct a house like having 10 separate water systems. Like you got 2 bathrooms, right? In a house, say you got 2 or 3 bathrooms. You don't want 10 separate water pipes going through the house. You want one system which is controlling the whole flow, like a heater, right? You have probably a furnace in your house, right? You don't want 10 different heaters just for each separate room. It's much more efficient and much more cost effective, right? For every month, if you have one furnace which is providing all that heat. So it's that idea of sort of centralizing and making sure that we're cutting down on how much code we have to run. And like Labdi was saying, once we cut down the amount of code we have to run, we're cutting down the complexity. And in like real life with that house example, we're cutting down the amount of money we're spending per month on like utilities, energy, right? So that's a good analogy you made right there.
Definitely. All right, so today, what are we going to use to try to abstract our code that we already have running for Mastermind? Well, we're going to use functions, parameters, returns mainly, and we can talk about what other ways we can further abstract the code. Now, before we do use these, we have got to learn what they are, right? So I'm going to share my screen to a blank replit. Ryan, would you be able to?
Yep.
All right, perfect. And here we go. All right, so I just have a blank replit and I will share that with you guys. Share that. Put that in the chat. So if you guys click on the link, you'll go straight to the project or file that I'm working on. All right, so what are functions? functions. And inside functions, what are our parameters and return statements. So who knows what functions are? You guys should know. We've gone over this. How about I'm going to start writing a function on the screen and then someone shout out as soon as you know what it is.
Definition. That one's a function.
Yep, so Love just wrote a function. Who can remind the class of what the purpose? You know, we talked about it in breakout rooms as well. Why do we create functions? What's the purpose?
Anyone? So I'm going to call that now. And run that. So this is inside a function. All right, since no one recalls, a function is basically you set aside lines of code inside something you can call many times. Now, when you declare a function, you just say, you tell the computer that when I call this function, if I do, then do these tasks. So if I say inside this function, I say print, this is inside a function, and then I'm going to say print another statement. Okay, so if I don't call this function and just declare it over here and I run, then nothing happens. But if I call that function, remember with the syntax, you got to add in parentheses after the name of the function and then run it, then I get whatever is inside that function is run. So functions are used in abstraction to be able to do similar things using less lines of code. So we did go over this around like week 1 or 2. But if I wanted to, let's see, remember when we printed hello 2021 from Lobby and then from Chase and then from Ayush. And then Rayan went ahead and Rayan used a loop back then. But what we can do is basically use functions. Sorry about the confusion, but I just realized Rayan used loops. So yeah, basically functions, you can do tons of tasks by just calling that. Now, when we add in parameters and return statements in functions, it just makes them way more interesting and you can use them in many more things. And here's how it works. So in a function, a parameter is always what you input. Think of a function as a machine. Let's say a mixer in your kitchen. You input vegetables, the mixer does its thing, and then outputs a sauce, something like that. That's a horrible analogy, but you guys get it. So inside this input, my parameters is the input. I'm gonna have let's say one parameter, and I'm just gonna call that param. And this parameter is a variable that, here, I'm just gonna take this out, that I say whenever this function is called using those parentheses, inside those parentheses, whatever variable is passed in, I'm going to have to use that inside this function. So if I say function, I define function 1 with one parameter, and instead of printing that statement that I had, I'm going to print the variable that I'm passing in. So I feel like this is a word in Python.
Yeah.
I'm going to call it param1. And then I call function 1, which is our function. And then instead of empty parentheses, so like open parentheses, close parentheses, inside those parentheses, I pass in whatever variable I want to. So let's say I pass in lobby. How about we have an opportunity to share? What do you think will happen when I call this function.
It will print lobby.
Yeah, yeah, definitely. That's totally true because we passed in the variable lobby, and then once we do get that variable in our function, what do we do with that variable? We just print it. And if we run it, that's what we're gonna get. Now, this looks pretty easy, and why do we want to use parameters when we can just print lobby over here? Well, there are different ways you can use functions. So if I say, let's say this is a number, and instead of printing that number, I'm gonna say that if, let's say, number is equal to 0, then print do task 1. Else, print, what do we want to print? Anything, I'll just do task 2. So instead of putting in lobby now, we are comparing our parameter with a number. So lobby was a string. Now we take that string out, and instead of putting in a string, we're gonna put in a number. Now if I put in a number 3 and run that, it's gonna do task 2 because number, which is 3 in this case, is not equal to 0. Now what if I want to keep this logic in, but I want to pass something else? So, suppose I want to pass in 0. What I'm gonna do is call the same function, but this time, instead of putting in 3, I'm going to put in 0. Well, what do you think is going to output from line 13?
So guys, if we're passing in the number 0, the conditional one.
It'll print do task 1.
See, this time again,
Yeah,
light
there we
coming
go.
from the same place.
So if we run, of course, it's going to print the do task 2 and then the do task 1, which it does. So now you see that using the same function, we can print 2 different things because our parameters were different. So this was parameters. Now let's parameters. Now let's go into return statements.
Exactly.
Now,
one quick thing before we get right there. So guys, we just saw Lavia is telling us about parameters, right? How we have one function which is telling us it has 2 different things, right? The purpose of this function is to tell us what type of task are we doing. Are we doing task 1 or task 2? Notice how Lavia didn't add anything else, like nothing else miscellaneous. There's only one main purpose of that function, and that's this idea of abstraction. Like, you know, if you have a kitchen, the purpose of a kitchen is to cook food, and that's where you serve your meals. It's not where you're taking calls, you're doing your meetings, you're using the bathroom. The kitchen has one purpose. Similarly, like a function, it has one purpose. And in this case, it looks like we're deciding what task we're doing. So that's an important thing to keep in mind as well.
Yep. All right. So in this function, we were printing stuff. Well, what if we want the function to give out a value to the code instead of just printing it in the console log? That's where the return statements come in. Now, I'm going to code one function that uses return statements and then explain what it does, and then we're going to code one together. Let's declare a function. Let's say def, we're going to do the same thing, assign task. And we are also going to put in some parameters. Let's say number. And then same thing, if number is equal to 0, then now here, instead of printing, I'm going to return true. Else, return false. Now, those were very weird lines of code, I know, but it's pretty simple if you think about it. Before I do start, you will notice that I used the same name for my parameter. Now, if we recall, in coding, you cannot use the same name for two different variables. If I say lob is equal to 0, I can't just say lob is equal to 2 again. Or I can, but okay. It will just use this variable instead of creating a new one. I'll have to say lob2 is equal to 2 to create a different variable. But over here in parameters, this number is only part of this function. It doesn't go outside. So I can use the same name for my parameters in different functions, and they won't change the other functions going in your code. So in this assign task function, what I have is I have a number as my parameter, and what I check inside that is a simple if statement. If the number is equal to 0, then do something else, do something else. Now that do something is return true. Now what does this return? What this is going to do is I'm going to set the value of this function to a variable. So I'm going to say function value is equal to, and then call this function. So is equal to assign task. And then inside that, of course, since this requires a parameter, I'll have to put in a number in here. Let's say we do put in a 2. So what this does is function value is a variable. So var is JavaScript. Function value is a variable. And then I assign that variable.
I was late. What is like the Replit link?
Replit link is in the chat. Rayan, can you?
Yeah, I'll repost it. Yep.
Okay, thank you so much. All right, so back to what we were talking about. Function value is a variable. And what are we assigning to that variable? Again, we have to assign a value to a variable. That's what variables are. But in this case, we're actually calling a function. Now, functions do tasks. They're not values. But in this case, what this function is doing is it's doing a task, and then it's returning a value, either true or false. So since I put in a2, I'm going to try to read through my code, and def assign task number, we put in 2. If number is equal to 0, then return true. Well, is 2 equal to 0? Yeah, no. Is 2 equal to 0? No. So it's going to skip this part and go into else and then return false. Now return false just means that the value of this function is false. Easy. And therefore the value of this variable is also false. And we will confirm that by printing function value. So I'm going to comment these two out and run. Takes a couple seconds. Now understanding returns, oh yeah, there we go. We do get a false. Now if we do change this to 0, let's say, and run it. What?
Probably choose your change there.
Okay, so if we do run it again with 0 as our parameter, we're going to get a true. Now, what I was saying is this all may look very confusing with returns parameters, but the important thing to know is abstraction. What Rayan said, abstraction makes our lives easier. So by doing one more step and creating functions with parameters and return statements, we can turn multiple lines of code into very few lines of code. I will comment this in. And there you have it. Rayan, do you have anything to add?
Yep, yeah. So guys, the main idea is, when we're looking at these return statements we got in the bottom part right here, you might be asking, okay, so this is cool. I'm being told true or false, but why not just, can't I literally just go in here and write print, this was true, and then do the exact same thing, and then just print right here, print this was false, right? What's the point of using a return statement? Well, the idea is print statements, we've used in our mastermind, there is a lot, right? There's so much being outputted, and at one point it can get pretty disorganized and cumbersome to keep track of everything being printed out. And it goes back to this idea of abstraction. It's a way for us to cut down and limit the amount of code we have to run. So now if we're running this function, it is telling us literally if the code we have ran, the condition is it true or false, returning us a Boolean, and we can then use that piece of information to make additional decisions. So whenever we can, it's highly recommended that we use a return statement to tell us what's going on instead of just throwing in some print statements. And this sort of relates us to this idea of debugging. You know, we were doing some live debugging with our mastermind project. We couldn't figure out how to, something going on with the while loop, I believe it was last 2 weeks ago. And we figured out that we threw in some print statements, but at the end, we ultimately took them out because they weren't part of our final project. So it's this idea of being able to simplify down. And that's why we are using return statements today as well.
Yep. So that was a lot of us talking. Now it's time for us to look at our mastermind project and see where we can
Implement.
yeah, where we can implement the abstraction. I believe I'm sharing the same screen. Sorry about that.
Now, same
Can I
thing for
have
the second one
the
as
Google
well.
Classroom code again?
Again, the light source is same, coming from this side.
Here it is. I'll put it back up for you. Actually, I'll drop in the chat. Lab, you wanna get that on? I'll drop the code in the chat, Krishna.
Okay, yeah, I'm just trying to find the replit. Okay, there we go. Here, mastermind abstraction. There we go, perfect. So what I've done is I've gotten. Oh, Rayan, you meant like start replit, right?
Yeah, you can start the replit.
Okay.
Yeah.
Okay, so what I have here is our code for mastermind, just 54 lines of code. And let's think about where we can abstract this. So what we learned today was trying to use functions and parameters and return statements to try to avoid doing the same things over and over again. It's time for you guys to think about, again, this is part of algorithmic programming.
Maybe since you said like I just heard you say like the things over and over again, when like maybe when a person guesses, like for example like the 4-digit number like 3457, but then they put the 3 and then in their second guess they put they do like 6453, like they still use the number 3, and maybe Kuya's function did not repeat that number.
Okay, that is very okay. That is intuitive thinking. So you're saying that if the number is 1, 2, 3, 4, and I guess 4, 3, 2, 1, I should at least get some sort of notification that I have the numbers right. Am I getting?
Yes, sir.
Yeah. Okay. So that is not abstraction of code, although that is just adding a new functionality to our game. Currently, the functionality, so what our game does, is basically compare the guess to the correct answer and then say which places are the same and which aren't. And then finally, if they do get the guess correct, we end the game. That's our functionality. Abstraction it means keeping the functionality the way it is, even if it's very simple, but changing the code that does the same thing, but way more efficient, with less complexity, and a little more organized. So just to help us on, think about the inputs. Now, we do get these inputs many times, right? 1, 2, 3 times. And we have to write the same line of code 3 times. So what if instead of writing this n equals int input, what is your guess for this 4-digit number, we can create a function and return that input instead of writing that line of code. How does that sound? I'm guessing we agree.
It sounds good, guys, because we're reducing the amount of code we got to write. Yep.
All right, so let's get started into first defining the function, because we have to declare a function before using it. So I'm going to say def, let's say input question, parentheses and the colon, enter. Now, if you take a look, this n equals int input, what is your first guess for this 4-digit number? That's different than these two inputs. What is your next guess? And then what is your next guess? So there are two types of inputs that we can make, and they depend on where we make them. This first one is obviously your first guess, and then these two later on in our while loop are the next guesses. That's where we use the parameter. Now I'm just going to say num, or let's keep this as string, first or next. That's a variable I called parameter variable. And inside this, I'm going to have an if statement. So if, and I'm going to compare. So if this variable is either first or next, so I'm going to compare if it's first, if this first or next variable is equal to first, then do something. I'm just going to print something for now. Hi. Else, just going to add an if just in case. Elif, our first or next parameter variable, first or next is equal to next.
And Avanish has a quick question asking us, what is the first or next? Remember, Avanish, the thing in between the parentheses is like a parameter. So that's like the variable which we're being passed in. So that's what Lobby's comparing right there with the conditionals.
Yep. So we're going to check this, if this works really quick. Enter, we're going to call this function, input question. And let's say we put in first. So what it should do, just going to comment the rest out, run, it should, nice. Because I commented this out. So keep our declaration of our function, and it should print out first. Now that was pretty easy. That's basically what we ran through in that other replit. Now it's time to actually, instead of printing first, what do we want it to do? We take a look at what we're repeating every time. It's n equals input, int input, what is your first guess? Now it's this functionality that we want to put in our function. So instead of printing, what we're going to do is we're going to return int input, what is your first guess? And then for the next,
this replit.
Yes, I will. Copy that. Okay. All right, so instead of we'll just call it over here. So instead of printing, yeah, that's what I was going to say. Instead of printing first or next, we're going to return what we were trying to set our variable n to. So if our parameter is first, then we're going to say, what is your first guess? Or if our parameter is next, then instead of returning the first guess, we're going to say, what is your next guess? Pretty simple, right? Now, how to use this function? Well, since we're returning something, recall when we had that replit, we had to set that function to a variable because we're returning a value. Same thing over here. Instead of inputting, just like calling that function, let's just replace whatever this is with that function. Well, what's the name of our function? Input question. And then over here, we're going to have the first question. So input question. And inside, I'm going to say first. Now, the reason you see this is because I'm declaring this function after I'm trying to use it. It's like you're trying to eat that lasagna before you made it. But you can't. So you have to make that function and then use it. And there we go. So we set our n equal to input function, and then we put in our parameter first. So I'm just telling the function that I want to get the input for my first guess. Now let's take a look at where else we want to use this. I'm just going to copy our line. Actually, no, it's not that much. So n is equal to, instead of int input, what is your next guess for the 4-digit number? All I'm going to say is n is equal to input question. Input question. And then instead of first, since this is next, I'm going to say next. And then same thing over here. Just going to copy that since they were doing the exact same thing. Paste. And that should work. Let's take a look if it does work. Give it a second. All right, what is your first guess for this 4-digit number? Yay, it worked. Okay, since first of all, we have to get the first guess. Any guesses? Let's just
5, 6, 7, 8.
Fast. 5, 6, 7, 8. All right. You didn't get any digits correct.
Yeah, 5, 6, 7, 8.
Yep, I believe that's what I did.
4, 3, 1, 2.
All right, 4, 3, 1, 2. Before we do move on, take a look. What is your first guess? That worked. First guess. What is your next guess? That worked. And basically just using this function that we just created, declared, and just calling that function every time we want that input, we have basically abstracted our code. And that's just one thing that we have done to change the code, but not the functionality. All right, so for what, 1, 3?
4, 3, 1, 2.
Oh, 4, 3, 1, 2. You didn't get any digits correct. Oh.
1, 2, 3, 4.
1, 2, 3, 4. Nope.
What are the chances?
7, 5, 6, 4.
1, 9, 8, 2. Oh wow.
Killing it, guys. We're killing it.
I'm not done.
What are the chances?
I'm not done.
Wow.
How much you done with? Can I see
Wait,
that?
1, 1, 1, 1.
Oh, oops. No.
Okay.
Okay, let's just
Okay,
try
okay.
Make
it.
sure when you're working with the
3,
circle,
5, 6, 0.
move your hand in the
3,
circular
5,
direction like
6,
this.
0.
Okay?
Oh, okay. We got 3. Yeah.
It should
3,
not
1,
be straight.
2,
It should be a
4.
curve.
1, 2, 1.
Yeah.
Okay, we got 2. Nice.
Okay, 3, 3.
Bala,
Yeah,
are you done with
3, 3, 2, 1. Or wait,
Not
what?
1.
4.
Let's try 6.
Yeah.
Nope. 3, 4, 2, 7. Nope. 3, 5, 8, 2. Oh, my bad. 3,
3, 0. Something.
2, 9.
Oh.
Oh my god. Okay.
Hey.
Let's
Let's
not-
We played them multiple times, but
yeah.
idea. We saw today how we reduced a bunch of code. We're not writing that same statement, that input statement 10 different times now, right? Not literally, but still. And it's pretty cool to see how we can use this idea of abstraction, guys, today and apply it to something we just made last week. So in the coming weeks, definitely look out as we.
Wait, I ran it on my end, and in the third one, I got 2 numbers at the same time.
That's great.
We'll hear some personal records. Keep on playing it, guys. You guys made it, so get yourself a pat in the back. But today does bring the end of our mastermind project. Although we'll reference it again, we worked on it a lot. Done a lot of cool extensions with this now as well. And hopefully you guys have had a good time. But remember, guys, tomorrow we have our Hack Central program. Hope to get you guys there. We're going to be doing something with something called Tkinter. It's a way for us to make cool things, which are graphical with Python. And then Wednesday, we got our product development course. And then on Friday, to wrap the week up, we have our video gaming hour, where we're going to be playing Pictionary, something different. So we hope
Yep.
to get you guys there. Take care and hope you guys have a good time. See you guys.
Bye, thank you.
Bye.